March 17, 2025. A deafening impact shattered the quiet near Buga, Colombia, leaving behind a flawless metallic sphere, seamless, 30 centimeters wide, resting at the center of a perfect ring of withered vegetation. Above it, severed power lines hung lifeless in the air. Scientists arrived expecting debris, evidence of a hoax, scattered fragments. Instead, they discovered 3 concentric shells, 9 internal spheres suspended in impossible symmetry, and a central chip, an object that appeared to be gaining mass with each passing hour. As the world scrambled for explanations, a quantum AI research team claimed to have deciphered its engravings, universal constants, golden spirals, gravitational wave patterns carved with precision beyond any human capability. What was truly discovered on that remote Colombian road? And who, or what, left it there? On the outskirts of Buga, the silence of early morning was shattered by a sudden blackout. Street lights flickered once, twice, then surrendered to darkness. At 3:11 a.m., a utility crew arrived to investigate the power failure. The lead worker, his boots crunching over brittle grass, found high-tension lines collapsed to the ground. The cables had been sheared clean, not frayed, not melted, but cut with surgical precision. Just beyond the tangled wires stretched a ring of scorched earth 30 feet across. Every blade of grass within that circle was bone-dry, brittle as autumn straw, while the vegetation beyond the boundary remained vibrant and untouched. At the center of the ring sat a metallic sphere, perfectly smooth, roughly the size of a soccer ball. No welds, no seams, no visible markings of any kind. Its surface caught the blue emergency lights of the service truck and threw them back, yet the metal itself radiated no heat. The worker reached out cautiously, expecting warmth from a crash or fire. Instead, the sphere was cold, unnaturally so, almost painful against his bare skin. He pressed his palm flat against the metal and felt something unexpected, a faint vibration, a low thrumming as if something alive pulsed within. Within minutes, neighbors had gathered along the roadside. One pulled out a phone and captured a short video. The orb seemed to emit a faint silver luminescence, casting shifting shadows across the dead grass. A soft humming filled the air, rising and falling in uneven waves that made people shift uncomfortably where they stood. Some in the crowd murmured about lightning strikes. Others whispered theories about crashed drones or fallen satellites. No one could explain the ring of desiccation. The soil itself had hardened as if baked from within, yet there was no evidence of fire, no chemical residue. Not even the sharp scent of ozone lingered in the air. A municipal police officer arrived, notebook in hand. He logged the object as unnaturally cold to the touch and noted something else peculiar. The sphere's weight seemed to increase slightly each time he measured it. The first reading on his portable scale showed just under 7 kilograms. 10 minutes later, the number had climbed by several grams. He checked the calibration, confused, then measured again. The result was consistent. The sphere was getting heavier. By dawn, rumors had spread throughout Buga. Some called it a meteorite. Others insisted it was an elaborate hoax. But the evidence scattered across the ground refused easy categorization. A flawless orb, a ring of dead earth, and power lines sliced as if by a single invisible blade. The sphere was loaded onto a flatbed truck and driven away, leaving behind only a circle of silence and scorched grass. The questions, however, were only beginning to multiply. At the National Autonomous University of Mexico, the sphere was wheeled into a laboratory lined with lead shielding and filled with a steady hum of diagnostic equipment. Dr. Carlos Munoz, a physicist renowned for his work on exotic alloys, led the initial imaging session. He requested a series of high-resolution X-ray scans, then ordered the team to switch to computed tomography for deeper analysis. The first cross-sections revealed something no one had anticipated. 3 concentric metallic shells nested with mathematical precision, each separated by gaps measured in fractions of a millimeter. Within the innermost shell, 9 smaller spheres hovered in a perfect lattice. Formation, apparently untouched by any visible support structure. At the geometric center, a chip smaller than a fingernail sat encased in the densest material yet measured within the object. Technicians recalibrated the scanners twice, suspecting a software glitch or calibration drift, but every subsequent scan confirmed the same impossible architecture. The outermost shell measured precisely 30 centimeters in diameter, matching the sphere's external dimensions. The middle shell, just under 27 centimeters, exhibited a subtle density gradient, a layering effect not seen in any terrestrial engineering. The innermost shell, barely 20 centimeters across, somehow held the microspheres and central chip in perfect suspension. No welds, no fasteners, no manufacturing seams whatsoever. Only a continuous expanse of alloy interrupted by the voids where the inner components floated impossibly in place. Dr. Munoz meticulously logged every scan, annotating the images with timestamps and scanner settings. He noted the complete absence of thermal expansion in the shells, even as the laboratory's ambient temperature fluctuated throughout the day and night. When the sphere was weighed again, the digital scale displayed a new anomaly. The mass, first measured at 7.02 kilograms, now reads 7.09. A second measurement taken an hour later showed 7.12. The team checked for accumulated dust, condensation, any possible material transfer. Nothing explained the steady drift upward. The scale was removed, professionally recalibrated, and tested on standard reference weights. It performed flawlessly. Only the sphere produced this creeping mass increase. Rodolfo Gerardo, a visiting engineer, suggested the sphere might be absorbing ambient moisture or absorbing outgassing compounds from the laboratory floor. But the shells showed no corrosion, no residue buildup, and generated no detectable electromagnetic field. Munoz ordered a comprehensive environmental sweep, humidity levels, air pressure, background radiation. Every reading came back ordinary. The object itself was anything but. Each new scan deepened the mystery. The arrangement of the microspheres obeyed a symmetry more precise than any known crystalline structure. Yet materials analysis, limited to non-destructive methods, could not definitively identify the alloy composition. The central chip, shielded by the innermost shell, reflected nearly all incident X-rays, producing only a ghostly outline on the imaging screens. Munoz wrote in his laboratory log, "No known manufacturing process could produce this structure. No known physical force explains its behavior." By the end of the week, the sphere's mass had increased by over 150 grams. The laboratory logbook, once a routine record of mundane measurements, now read like a chronicle of mounting impossibility. The imaging team prepared their comprehensive data for external peer review, but the chain of custody quickly grew tangled as military and government officials arrived to secure the artifact. The sphere was relocated to an undisclosed facility, leaving behind only a hard drive of scans, a stack of weight measurements, and one unanswered question: what mechanism, if any, could explain the sphere's internal order and its inexplicably shifting mass? A week after the laboratory scans concluded, the debate shifted from the sphere's physical structure to the puzzle of its surface. A set of shallow engravings, barely visible except under raking light, formed an intricate script that defied straightforward translation. At this point, a spokesperson from a quantum AI research team stepped forward. In a press conference streamed from their Zurich office, she described feeding high-resolution images of the markings into a hybrid quantum classical algorithm designed for symbolic pattern recognition at scales no conventional computer could match. The software, she claimed, had mapped clusters of symbols directly onto four of physics' most fundamental constants: Planck's constant, the fine structure constant, the speed of light, and Newton's gravitational constant. Not as random digits, but as precise mathematical expressions, ratios, exponents, and spirals encoded directly into the geometry of the marks themselves. She held up a printout for the cameras. One spiral's arc length divided by its radius yielded a value within a fraction of a percent of 6.626 times 10 cubed, Planck's constant. Another cluster, spaced according to the Fibonacci sequence, produced a ratio matching the golden mean of 1.618 within the tolerance of a scientific calculator. The AI had flagged cross-references between symbol groupings and the known spacing of atomic spectral lines, mapping them to the fine structure constant alpha and to the speed of light in meters per second. These results, she explained, had been independently replicated by running the dataset on both IBM's 1121-qubit Condor processor and Google's Sycamore quantum core, each returning identical pattern matches within minutes. But the spokesperson paused, careful not to overstate her claims. No source code, no raw training data, and no annotation logs were released for public scrutiny. The team's findings remain precisely that: claims, not demonstrations. Quantum processors, she reminded the assembled reporters, excel at certain classes of search and pattern recognition, but they do not conjure meaning from noise or cracked ciphers without proper context. The sphere's engravings might encode a universal language, or they might simply reflect humanity's deep-seated tendency to perceive order in chaos. For now, the only certainty was this. If the patterns were intentional, they had been mapped to the very numbers that define physical reality itself. P. Marcello, a physicist specializing in condensed matter, published the first theoretical model attempting to make sense of the sphere's internal architecture. His paper, circulated among academic preprint servers, proposed that the 9 microspheres and nested shells were not merely decorative. They formed a resonance device engineered to manipulate electromagnetic waves within the orb. The model drew on established research from photonic crystals and metamaterials, fields where scientists have successfully coaxed light into bending, slowing, or even seeming to vanish inside carefully engineered lattices. In Marcello's simulations, photons injected through the outer shell would ricochet between layers, establishing standing wave that locked into stable patterns only when the geometry matched exact mathematical ratios that mirror the golden spirals and Fibonacci sequences found in the engravings. He described how, in laboratory metamaterials, a lattice of precisely spaced rods or cavities can bend microwaves around an object, effectively cloaking it from detection. Here, the sphere's shells and microspheres could function as a three-dimensional resonator, shaping not just light but any electromagnetic field that penetrated the structure. The 9 internal spheres, arranged in a lattice more precise than any natural crystal, would serve as nodes, points where energy could accumulate, interfere constructively, or transform into new wave patterns. The central chip, shielded by the denser shell, might operate as a control node, fine-tuning the harmonics or switching between operational states. No one has yet observed such effects directly in the Buga Sphere. The resonance model remains a hypothesis, untested in the absence of open access to the object or its raw measurement data. Still, Marcello's proposal anchors a debate in established physics. Photonic processes exist in university laboratories worldwide. Metamaterial cloaking devices have successfully bent light around millimeter-scale objects. The sphere's geometry, if intentionally designed, would represent an exponential leap beyond anything achieved in current photonic engineering, a device capable of processing electromagnetic waves not with silicon or software, but with structure alone. For now, the only evidence consists of the sphere's silent architecture and the computer simulations hinting at what might be possible within its nested shells. In late spring, a new claim rippled through research channels. A graduate student reviewing the eye's symbol-to-constant mappings noticed a familiar curve in one of the sphere's deepest engraved layers. Not a number or spiral this time, but a pattern of rising and falling waves, compressed, then stretched, then fading to silence. The waveform, when carefully charted, matched the so-called chirp recorded by LIGO on September 14, 2015. That was the day 2 black holes, each dozens of times more massive than our Sun, merged over 1 billion light-years away, sending a tremor through space-time itself. The LIGO collaboration announced their discovery months later, on February 11, 2016, after exhaustive data verification and peer review. Their signal was unmistakable, a low, swelling note rising in frequency and amplitude until it abruptly ceased. The pattern engraved on the sphere's shell, if traced in sequence, appeared to mirror this signature down to the final spike. Physicists who reviewed the overlay called it provocative but warned against premature conclusions. No raw overlaid data, no statistical analysis, no peer-reviewed correlation study had been published. The LIGO chirp is publicly available, its shape well documented, but so are the well-known dangers of pattern-seeking behavior in ambiguous data. Is this a cosmic coincidence, a deliberate reference, or a case of humans seeing what they desperately want to see? The claim stands unproven, yet the timing and the level of detail are difficult to dismiss. For those who believe the sphere carries an intentional message, the implication is staggering, a direct link to the moment humanity first detected the universe's gravitational symphony. For skeptics, the absence of rigorous verification serves as a necessary caution. The sphere's engravings, whether designed or accidental, now stand accused of referencing the most dramatic observational event in modern astrophysics, a cosmic collision that fundamentally reshaped our understanding of the universe. The debate, for now, remains unresolved. Astronomer Dr. Elena Rivas received a comprehensive dataset of the sphere's engravings and internal arrangements, searching for patterns beyond familiar physical constants. She began with the 9 microspheres, plotting their relative positions against known orbital resonances within our solar system. The spacing, she noted, bore a remarkable resemblance to the Laplace resonance among Jupiter's moons, Io, Europa, and Ganymede, where gravitational interactions keep their orbits locked in precise rhythmic ratios. Further analysis revealed proportions that echoed the gaps in Saturn's rings, and a subset of symbols corresponded to periodic spacing of fast radio bursts and pulsar coordinates catalogued by international radio observatories. One particular cluster of engravings, when carefully mapped onto a standard star chart, pointed not toward any known celestial object but to a patch of deep space between constellations, an empty coordinate marked only by silence and the faint background glow of distant galaxies. Rivas cautioned that the universe is vast and patterns abundant. Finding apparent connections between geometry and cosmic phenomena can be as much artifact as evidence. The human mind excels at detecting patterns, sometimes finding them even where none exist. Still, the hypothesis lingered uncomfortably in the minds of those who studied the data. The sphere's engravings might chart an actual map, or they might simply mirror humanity's ancient drive to find order and meaning in the stars above. Stories of cosmic eggs and world-seeding spheres echo across centuries and cultures. In the valleys of Colombia, elders recall tales of the Huevo Divino, a luminous orb said to appear at moments of great upheaval, always perfect, always silent, always vanishing before dawn. The Buga Sphere's arrival triggered an immediate wave of cultural comparisons, creation myths, ancient omens, even the golden apples of distant legends. On social media, these echoes collided violently with viral rumor and speculation. In late March, a single tweet claimed that a second sphere, smaller, just 8 inches wide, had surfaced in Japan. Screenshots of a metallic orb perched on a riverbank in Shizuoka Prefecture spread rapidly through forums, YouTube Shorts, and conspiracy theory channels. Bloggers linked the image to the Buga case, weaving it into an expanding mythos of global sphere appearances. But no Japanese laboratory or government agency confirmed the find. Local reporters eventually traced a photograph to a scrap metal yard. The supposed orb was nothing more than a misidentified industrial float, weathered and ordinary. Still, the idea took root. The legend grew, fueled by retweets and late-night speculation. In a world hungry for meaning and connection, even silence can be filled with stories. Stephen Greer's name began circulating online alongside a specific number, 12,560 years. According to various posts and interviews, a resin sample supposedly extracted from the sphere had been sent to the University of Georgia Center for Applied Isotope Studies. The result, they claimed, placed the artifact's origin deep in the late Ice Age, millennia before the rise of agriculture, cities, or written language. Yet as the story spread, the foundation beneath it crumbled under scrutiny. No laboratory report was ever publicly released. No raw measurement data, calibration logs, or sample chain of custody records appeared in any scientific archive or database. University officials declined to comment, citing confidentiality agreements and ongoing internal review processes. Without a peer-reviewed publication or even a formal summary from the laboratory, the age claim remains in limbo, an unverified figure amplified by social media but unsupported by the rigorous protocols that define scientific fact. Calls for transparency have only intensified. Researchers, journalists, and independent analysts have demanded the release of all primary data, radiocarbon spectra, sample preparation documentation, calibration curves, and analytical protocols. Only then can any extraordinary claim be properly tested, independently replicated, and either confirmed or overturned. Until that happens, the sphere's true provenance remains an open question, one that science is fully equipped to answer, but only if every step of the process is made transparent and available for scrutiny. X-ray scans documented 3 concentric shells, 9 suspended microspheres, and a central chip, along with a measured mass increase over several days under controlled conditions. Claims that quantum AI decoded engravings into mathematical constants and gravitational wave signatures remain unverified, as no primary datasets, algorithms, or source code have been released for independent analysis. Computer simulations linking the sphere to photonic resonance effects and metamaterial properties draw on legitimate scientific research, but their specific application to this artifact remains unproven and untested experimentally. The origin date of 12,560 years, attributed to a resin sample, has not been independently confirmed through peer-reviewed studies or transparent data disclosure. To date, the Buga Sphere's physical anomalies are real and documented under laboratory conditions, but its purpose, its origin, and its true nature remain fundamentally unresolved. The evidence demands open, transparent science conducted according to established protocols. It reminds us of a fundamental principle: extraordinary claims require extraordinary proof, and that proof must be available for anyone to examine, question, and verify. The sphere waits in its undisclosed location, silent and perfect, guarding its secrets. The questions remain suspended, like those 9 microspheres floating impossibly within their nested shells, waiting for answers that may change everything we think we know about our place in the cosmos. October 14th, 2025. 7 months after the sphere's discovery, Dr. Munoz received an urgent call at 2:47 a.m. The military facility housing the artifact was reporting unprecedented activity. He arrived within the hour to find the secure laboratory in controlled chaos. The sphere, which had sat dormant for months in its containment chamber, was no longer cold. Thermal sensors registered a steady temperature increase, not dramatic, but consistent, climbing 1 degree every 8 minutes. More unsettling was the light. A soft blue-white luminescence had begun emanating from within the shells, visible through the microscopic gaps between layers that the X-ray scans had revealed. The humming sound, last heard on that March night in Buga, had returned, but now it resonated at multiple frequencies simultaneously, creating harmonics that made the instruments on nearby tables vibrate in sympathy. "It's responding to something," murmured Dr. Rivas, who had been called in alongside Munoz. She pulled up astronomical data on her tablet, hands trembling slightly. "There's a gravitational wave event. LIGO detected it 3 hours ago. Another black hole merger." The timing was impossible to ignore. The sphere's activation had begun within minutes of the gravitational wave passing through Earth. Within the containment chamber, the 9 microspheres that had floated motionless for months began to move. Slowly at first, then with increasing precision, they rotated within their invisible framework, tracing paths that formed a 3-dimensional pattern, a dance of perfect geometry that repeated every 47 seconds. Marcello arrived with his simulation equipment, setting up hastily in an adjacent room. "If my resonance model is correct," he said, typing frantically, "those microspheres aren't just moving randomly. They are processing the gravitational wave, filtering it, analyzing it somehow." The central chip, previously invisible except as a shadow on scans, now pulsed with its own rhythm. Each pulse corresponded exactly to peaks in the gravitational wave data streaming from LIGO's servers. Then, at 4:23 a.m., something changed. The engravings on the sphere's surface began to glow, one symbol at a time, in sequence. Not the entire surface, just specific clusters. The same clusters a quantum AI had mapped to physical constants. They lit up in a pattern that took 41 seconds to complete, then repeated, and repeated again. "It's broadcasting," whispered a technician monitoring electromagnetic frequencies. "Low frequency, directed signal. And it's not random, it's structured, mathematical. It's a response." Dr. Rivas checked the astronomical coordinates her earlier research had identified, that empty patch of space between constellations. She pulled up the latest Deep Space Telescope data. "There," she pointed at the screen. "Right there. An infrared signature that wasn't in the archive 6 months ago. Something's there. Something faint, but it's there." The room fell silent except for the harmonics emanating from the sphere. "What have we found?" Munoz asked, though no one seemed to expect an answer. The sphere continued its pattern for 6 hours and 17 minutes. Then, as suddenly as it had begun, it ceased. The light faded. The temperature dropped. The microspheres settled back into their original positions. The only evidence of the event was the data, gigabytes of measurements, recordings, and observations that would take months to analyze fully. But something fundamental had changed. The sphere's mass, when measured the following morning, had decreased by exactly 150 grams, returning to its original 7.02 kilograms. 2 weeks after the activation event, the quantum AI team published their analysis of the light sequence. The pattern of glowing symbols, when decoded using the same algorithm that had identified the physical constants, formed something unprecedented. A set of coordinates in 11-dimensional space-time, accompanied by what appeared to be a timing sequence. "It's an address," explained a Zurich spokesperson in a hastily arranged press conference. "And an invitation, or a warning. We can't be certain which." The timing sequence, when cross-referenced with astronomical data, pointed to a specific moment, February 3rd, 2026, just over 3 months away. On that date, Dr. Reavers announced to a packed auditorium, 3 celestial events will align. A solar eclipse visible from South America, a rare SYZYGY of 4 planets, and, according to predictive models, another gravitational wave event from the same region of space. The probability of these occurring simultaneously is... She paused, checking her calculations one final time. 1 in 4 to 7 million. The sphere had known. Somehow, impossibly, it had known 7 months in advance. Governments worldwide entered closed-door sessions. Observatories redirected their instruments toward the coordinates. The James Webb Space Telescope devoted precious observation time to scanning that empty patch of space between constellations. They found something. A structure, artificial, vast beyond comprehension. Not a ship or a station, but something that bent light around itself, becoming visible only when viewed from a specific angle, an angle Earth would reach on February 3rd, 2026. The Buga Sphere, it seemed, was not a message in itself. It was a key, an announcement, a way of saying, "We are here, we have been watching, and soon we will meet." The world held its breath. In the secure facility, the sphere sat in its chamber, monitored by dozens of instruments and hundreds of eyes via remote feeds. Scientists, military personnel, and world leaders watched from bunkers, control rooms, and secured locations across the globe. At 11:47 a.m. Greenwich Mean Time, as the solar eclipse reached totality over Colombia and the planets aligned in the pre-dawn sky, the gravitational wave reached Earth. The sphere blazed alive. This time, the light was blinding. The 9 microspheres spun so rapidly they blurred into rings of pure luminescence. The harmonic frequencies reached a crescendo that shattered 3 observation windows despite their reinforced construction. And then, for exactly 7 seconds, every television screen, computer monitor, and smartphone display on Earth went white. Not black, white, pure, sourceless light. When the displays returned, they showed a single image, a 3-dimensional schematic of the Milky Way galaxy, rotating slowly with 2 points highlighted. One was Earth. The other was that patch of empty space, now revealed to contain a structure older than human civilization, older, perhaps, than humanity itself. Beneath the image, in every written language simultaneously, appeared words that no AI had generated, words that existed in no database. You heard the universe sing. We heard you listening. The silence is ending. The sphere went dark. Its mass dropped to 0. When technicians opened the containment chamber 3 hours later, after every conceivable safety protocol had been exhausted, they found only a perfect circle of fine metallic dust arranged in a spiral pattern, the golden ratio, visible even in its dissolution. The central chip was gone. The shells had evaporated. Only the data remained, and the knowledge that humanity had been noticed. In observatories worldwide, telescopes trained on those coordinates captured something extraordinary. The structure was moving. Slowly, impossibly slowly by cosmic standards, but unmistakably. It was moving toward our solar system. Current estimates suggested arrival in 847 years. Dr. Munoz, standing in the empty chamber, stared at the spiral of dust and spoke to no one in particular. It wasn't a warning. It was a timer. We have 847 years to prepare for whatever comes next. The Buga Sphere's purpose, at last, had been revealed, not as an artifact to be studied, but as a herald, a cosmic calling card left by beings who had mastered gravitational waves, who could encode the universe's fundamental constants into metal, who had watched and waited for humanity to reach a threshold, the threshold of being able to listen to the cosmos itself. The age of isolation was over. The questions that remained were no longer about what the sphere was, but about what came next. And in laboratories, universities, and research facilities across Earth, a new generation of scientists began preparing answers for questions humanity had only just learned to ask. The silence, as promised, was ending, but what would fill it remained to be seen.